Yeah, I don't see the flickering. I think it's a little bit better. All right, so good. Some of you took advantage of the long weekend. That's great. Let's see, some announcements. I moved, as you know, as hopefully most of you know, I moved homework 5 back to Wednesday, so you could enjoy the long weekend. And also, I moved my office hours up from Thursday to Tuesday. Homework 5, hopefully you've started it. If not, you may be in for a little bit of a surprise. It's a very different homework as we discussed. It's very mathematical. The questions are interlocked, interconnected. It's a real world problem instead of a bunch of individual problems. So if you haven't started, definitely start. And you have that office hours on Tuesday this time. So if you do, as long as you get started and start working through it, if you get stuck before office hours on Tuesday, you can pop into my office hours and ask questions, and I'll try to help. I do have a meeting at noon that day. It should be done, and I should be back home by 2. But if you log in at 2 and I'm not there, just try back a little bit later. And they normally run from 2 to 3:30. Okay. Let's see what else here. Right. So we still had class on Friday because I was still required to video. Yeah, my video is blinking. So if we do get the blue screen, just be patient, and it'll take about 15 minutes for me to come back, but disappointing. Anyway, yeah, so we still had class last Friday because I am required to teach the hours, and a few of you showed up, and that was nice to have someone interact with. And then I posted the video, so the rest of you hopefully have had a chance to look at that. If not, you should look at it very soon. We went through the rest of homework 5, the things you know to answer questions 7, 8, 9, and 10. 7's perhaps the most challenging one, where we're measuring the mass of this new fictitious planet by watching a moon go around it. Today's warm-up question uses the same mathematics. It's a slightly different context. Here we're trying to figure out the mass of a distant star. So as I've mentioned before, as you know, we've been discovering lots of worlds around other stars, and we'll talk about them near the end of the course. But in this particular question, we have a star and we have a planet going around it. And I give you the orbital properties of the planet, how far it is from the star, how long it takes to go around. And so I want you to figure out the mass of the star. And I already have 36 responses, and I'm trying to see how many people are here. Yeah, we have quite a few. So I'll give you another 30 or 40 seconds. If you know how to do it, it's pretty easy. If you don't, well, it might not be as easy. So I'll give you some time. And if you enter something and the number doesn't move, let me know. Oh, no, it's moving. Okay, there we go. See if we can get it up in the mid 40s. Another 30 seconds. All right, you can keep answering, of course, but let's see how we're doing. Got a bunch of answers here. I'm gonna take a look at the histogram, and yeah, so most of you got it just fine. 10 is the answer. So this is not just Kepler's third, but Newton's form of Kepler's third done as a ratio exercise. Here's the answer here. The mass measured in solar masses is equal to the semi-major, oops, 1 second. The semi-major axis cubed, where that's measured in astronomical units, divided by the orbital period squared, measured in years. And we know we can use these units because if you take the case of Earth going around the sun, it's 1 and 1 and 1, so everything equals out. Earth going around the sun is the comparison case in this ratio problem. And so just 10 cubed divided by 10 squared equals 10. Again, these ratio problems, once you wrap your mind around them, they're pretty easy. Okay. And I'll have another one tied to lesson 5, homework 5 next time. Okay, so let's see. Where were we? We were talking about, I'm just watching my screen flicker and incredibly nervous that we're going to have the blue screen and lose contact again today, but we haven't had that problem for a while. Anyway, yeah, we were talking about the exploration of the solar system. Lesson 5 is kind of an introduction to the rest of the course to come. We talked about the discovery of the solar system from a historical point of view. Then we've been working through this problem set on once we discover a world, what are the basic observables? What are the bulk properties of the world that we can calculate from these basic observables? And then we moved in last time to the exploration of the solar system. So this is getting into the modern era where we have spacecraft that we can send to the far reaches of the solar system and really start to get to know these worlds in much greater detail. We were wrapping up, we had pretty much wrapped up the inner solar system. And I told you, I put a link down in the WebAssign announcement area, 7 Minutes of Terror. So we were talking about the missions to Mars, beginning again in 1997 with a really small rover, and then later Spirit and Opportunity with larger rovers, and Curiosity. And we talked about the landing of Curiosity, the jet-powered sky crane, which is just absolutely insane from an engineering point of view, but it worked. It came in and the sky crane blasted its jets so it could hold itself kind of stationary as it lowered the Curiosity rover down to the planet. And it's been rolling around for quite a while. And we have another one on the way. I believe it's the same kind of delivery technique, and we can check on its status. It's called Perseverance, and it's similar in size. Its mission is more to look for ancient evidence of life, and it's also going to have a little helicopter on it. So we've been talking about landers that spit out rovers, and this one's going to have a little helicopter that's going to try to fly in the thin Martian atmosphere to cover more distance. It's the same kind of entry technique. Here's kind of a drawing of it right now. And it's currently 42% of the way there. It should get there on February 18th in 2021. And it's traveling, what, 63,000 miles per hour at the moment. You can just see the miles ticking by, which is just ridiculous if you think about it, but that's pretty cool. Okay, so that's the next big one in this sequence. And the Mars program is really gearing up for looking for evidence for either ancient life or possibly current microbial life, but most likely ancient fossilized life. But first, just looking for chemical signatures and things like that. Okay. That is the inner solar system. So let's move on to the outer solar system. Again, this is just kind of a preview, overview of the spacecraft missions with a few slides for each world to wet the whistle, and then we'll dive into the worlds in more detail. So this table, like the other one, is a little bit out of date. It shows the missions to the outer solar system. There have been a couple more since then. We see a lot of flybys. Again, that's pretty much the easiest thing you can do. And the next level is going into orbit. And we've had 2 orbiters now for Jupiter. Galileo in the 90s, and new one, Juno, is out there right now. One orbiter for Saturn, and it came with a probe. Actually, Galileo had a probe that went into the Jovian atmosphere. Cassini had a probe called Huygens that landed on Titan. So we've landed on the moon Titan, which is pretty cool. And also we've had the New Horizons mission that it went past Jupiter and out to Pluto and the Kuiper Belt. But otherwise, that's pretty much it for the outer solar system. And you see the same missions occurring over and over again. We see Pioneer 11 twice, Voyager 1 twice, Voyager 2 4 times, New Horizons. And some of these they don't show, like Cassini did go by Jupiter to get there. So it does actually have some Jupiter data as well, and New Horizons. And the reason we see them over and over is to get to the outer solar system, we use the gravitational slingshot technique. We could just go on our own rocket power and it would take a long time to get there. But what we do is if we want to go to Jupiter, fine. But if we want to go beyond Jupiter, we often still go to Jupiter. And if you come in behind the planet's motion, you can get a gravitational assist. It can kind of grab onto you gravitationally and transfer some energy, boosting your speed and changing your direction. Of course, you have to plan it really carefully so you end up going where you want to at the right speed to get to your destination when that next planet will be there. But we can do this, and we have been doing this kind of stuff since the late 60s and 70s all the way to the present day. So gravitational slingshots. The most famous example of this is Voyager 1 and 2. There was a mission before this called Pioneer where they practiced some of this stuff. But Voyager 1 and 2, for me, was super exciting. You can see the launch. They were just a couple weeks apart in 1977. I was born in January 74. So I got to watch this throughout my childhood. I graduated from high school in 91, and the last encounter with Neptune was 89. So this happened during my childhood. And as I was talking about last time, we'd never seen these worlds up close. We have some fuzzy pictures from telescopes here on Earth. We didn't have Hubble Space Telescope either. So just really poor imaging, ground-based kind of stuff. And so getting up close to these worlds for the first time was super exciting. It's one of the motivators for me to go into astronomy was this mission. Other things would be Cosmos, which is back on TV with Neil deGrasse Tyson, but the originals were by Carl Sagan. And probably also seeing Star Wars as a 5-year-old in theaters. That's probably my other big motivator. But anyway, tangents. So they left in 77 and arrived at Jupiter a couple months of more than a couple months, maybe about, March, April, May, June, July, about half a year apart in 79. And then Saturn in late 80 and late 81. So there's a time differential that's building up. Voyager 1 then went off into deep space, but Voyager 2 continued out to Uranus in 86 and Neptune in 89. We call that the Grand Tour. Nothing else has been out to Uranus and Neptune since. And, we'll talk a lot about these worlds throughout the rest of the course, but we'll also spend pretty much the same amount of time on the large moons of the solar system. The planets are interesting, but the large moons are larger than Pluto, which we called a planet for the longest time. Just because they orbit one of these other planets, most of them around gas giants, doesn't mean they're not interesting. They're worlds in and of their own right. One, of course, goes around us. Our moon is one of the 7 large moons of the solar system, which is really kind of strange because we're a tiny planet. To have such a large moon is unusual, at least in our solar system, we're the only case. The rest of them go around the gas giants. 4 of them going around Jupiter, Io, Europa, Ganymede, Callisto, discovered by Galileo, and then 1 large one around Saturn, Titan, and 1 large one around Neptune, captured from the Kuiper Belt farther out, Triton. So we'll spend a lot of time on these as well. In terms of missions, let's start with Jupiter. This is the Galileo mission, launched in the 90s. And on its way, it had a few close encounters with asteroids, completely planned. It's not like in Empire Strikes Back where you have to dodge asteroids to get through the asteroid belt. It's mostly empty space. If you don't plan for it, you would go completely through never seeing an asteroid. But if you plan for it, you can have a few close encounters. This is when we learned asteroids could have moons. This is Ida with its moon Dactyl. And then eventually it got into Jupiter orbit, and we see Io there, it just dwarfed by the immensity of Jupiter. And we started getting close-up pictures of these worlds, and we have tremendous surface information, even information about the interiors that we've learned in different ways. So we understand these worlds a lot better. Now, this is the Galileo spacecraft. This is Galileo the person. So we've come a long way over the past 400 years. For Saturn, now, and I should say we have another mission. I did say another mission, Juno, that's out there now that's providing some pretty spectacular images. It's in a polar orbit, so it's doing something a little bit different. This is Cassini, our first orbiting mission to Saturn, carrying the Huygens probe. Here's a picture it took of Saturn as it was approaching, which always amazes me. This looks completely computer generated. It doesn't look real to me. But it is. This is what it looks like if you can get up close, just this large, majestic world. Get up close with modern cameras, or even these cameras, well, they're more modern than anything that's ever been out there. And it also orbited for a long time and had lots of close encounters with the moons. And here we have Titan, the large moon of Saturn. And it's unique among the 7 large moons in that it has an atmosphere. And it's hazy. We can't really see through it, not at visible wavelengths. It has enough mass that it can hold on to an atmosphere, and it's far enough from the sun that it's cold. If an atmosphere is warm, we'll learn that since it's warm, it's bouncing around and it just bounces off into space and you can lose it. This is just enough mass and just enough coldness that it can retain its atmosphere. We never knew what was under there, but Cassini had an infrared camera that can peer through the haze. And here you see kind of a patchwork presentation, because every time it zipped by it imaged a different part and they pieced it together, some in better focus, some in less. But you see broad white areas, that's frozen water ice. It's really cold down there, so water is frozen. And then you see dark areas, and that's methane. And we think of methane as a gas, but at these temperatures, it can be liquid or solid. In most of these regions, it's kind of a sludgy methane residue. But we dropped the Huygens probe, and it took pictures on its way down. If you stitch them together, it was descending towards one of these methane sludge pools. And if you look on the edge, you can see riverbeds. So it's flowing liquid, not water. The water's frozen, but flowing methane on frozen water, ice land. So a different, very different world, but there's liquid moving on the surface. So people sometimes think about this in the context of life. It'd be very different life. Our life is carbon and water based. Here you have a liquid, which is a requirement for life, as we'll talk about later. I wouldn't bet money on life being there, but it's interesting. And it has a weather system with rain and you know, the methane's in all 3 phases, like water is here on Earth. And we have found methane pools. Here, this was just sludgy residue. We can tell because it's bumpy and lumpy. But using radar from Cassini flying over the top of Titan, we found that near the North Pole, there are a lot of methane lakes. So very interesting. And then we have Voyager. This is Voyager 2. And again, the only probe to get out to Uranus and Neptune. And it discovered rings. All the gas giants have rings. Saturn has the big, beautiful rings. The rest have piddly, small, leftover rings. And we'll learn why that is. And then eventually onto Neptune, where we saw this great dark spot. We thought it was the analogy of the great red spot on Jupiter, which has been there ever since Galileo first looked. But the great dark spot on Neptune is gone. So it was just transitory, so something a little bit different. A hurricane, a storm of some type, but not permanent. And then coming over across Neptune, we then saw Triton. And this, you know, it was interesting too. These black streaks are nitrogen geysers. So there's all sorts of surprises every time we encounter a new world. And that's part of what we're going to figure out for the rest of the course. Why aren't these worlds all the same? They're all dramatically different, but we can tie these differences to just a few simple physical principles. and then everything else follows. Then getting farther out, this is more recent. This is the New Horizons mission. It went gravity-assisted Jupiter and then went out to Pluto in 2015. It's the first we ever saw Pluto up close. And here's a picture from Hubble Space Telescope before it got there. And the funny thing about New Horizons is when it left Earth, Pluto was a planet. By the time it got there, it wasn't a planet. And they're the one of the few groups left that refuse to acknowledge that Pluto has been demoted. They still think, and they're still active, they're going out to another object beyond Pluto, but they still think it's a planet. Anyway, this is a Hubble Space Telescope picture where they've kind of blocked out most of the light coming from Pluto and its large moon Charon. So you can see some of the, so you can see fainter things, and there are 4 moons here. This was the discovery of Styx. And then New Horizons got there, and we got to see Pluto up close with its heart-shaped feature on it, and Charon, which is quite large. And we saw it up close in this dark region up here that they named Mordor. So, you know, scientists are nerds, so we name things accordingly, I guess. And here you can see kind of the best picture we have of each of Pluto's moons, a very busy active moon system, and here's Charon next to it for scale. Now, Pluto is not the only dwarf planet we visited. We have visited Ceres in the asteroid belt, also in 2015, with the Dawn mission. And so here's just a drawing of that. It visited 2 asteroids, Vesta and Ceres, the 2 largest things in the asteroid belt. Here are the best pictures we had of them before the visit from Hubble Space Telescope. You can see some features, but it's a little bit blurry because they're so small. It went to Vesta first and orbited around for a while. And so we got a really close-up look at that, and then it fired its thrusters and moved over to Ceres, which is dwarf planet. You can see it has pulled itself into a smooth shape. Vesta, not as much, and it's one of the requirements for being a dwarf planet. Ceres makes that, meets that criteria. And you have this kind of bright spot down in the crater that was interesting. People thought maybe it was water ice, but it seems to be more of a salt flat. And so the planetary geologists are having all sorts of fun trying to explain it. There are actually 300 of these that they found on Ceres. We've visited smaller things as well, have landed on smaller things. This is the asteroid Eros, and it's a near-Earth asteroid. It comes close to the Earth. It's not going to hit us, but there are a handful of asteroids, large ones that have orbits that are close to us. So NASA put out this mission called Near-Earth Asteroid Rendezvous, which went to a number of these and ended its mission here at Eros in 2000. And actually, it was the end of the mission. They were out of money, and the thing was never designed to land, but they said, what the heck, let's try anyway. And so on Valentine's Day, which is appropriate since this is Eros, we landed on the surface and crash landed. We went down gently, but it still busted the spacecraft. Here's the last picture taken. You can see how the transmission was cut off mid-transmission. But this is, I don't know, maybe about 10 feet across. You could print this out as a large poster and stand on it, and it would be kind of to scale standing on an asteroid. Also, comets. We've crashed into one and on purpose and landed on another. This is the Deep Impact mission, where there's a Deep Impact was the spacecraft. It flew by and it dropped a weight, and the weight hit the comet on purpose and blew up a region the size of a football field. Now, of course, we did this on January 4th, so we have fireworks. We'd like to hit the holidays, I guess. Or I'm sorry, July 4th. And the goal here wasn't just to do this for the fun of it, although it's pretty cool. It was to throw a lot of this primordial material out into space so we can study it spectroscopically using the large telescopes back here on Earth. Comets are primordial. They're made of the original stuff of the solar system, and there's no real geological activity. So if you can blast some of it up, you can study it and kind of figure out what the early solar system was made of. And this one, I'm not going to try to pronounce it, named after a couple long Russian names. In short, it's 67 PG-G, no, PC-G. And the Europeans went to this one with the Rosetta mission. Here's a drawing of it. And it had a lander called Philae. And it landed, unfortunately, in a shadow an artist has kind of drawn in where we think it landed among some difficult to visualize pictures. It's in a dark spot, so it's really hard to see. And so it's solar powered. Its batteries died almost immediately. But we did land, and they did get like an hour or so of data from the surface of the comet, which resulted in like dozens of papers, just that 1 hour's worth of data. But it's too bad it didn't land in the sunlight, and it would have ridden the comet around the sun and witnessed all the changes that happens to comets as they approach the sun. So before we hit the moon here, let's just make a list. I've given you lots of information, and I'm not going to hold you to all of it. This is more just kind of fun intro to get you excited about the stuff to come. You put the doc cam up and make a list of where we've been and how we've been there. So we've sent spacecraft to all the planets now, and 2 dwarf planets, Pluto and Ceres. These were both recent in 2015. And also to asteroids and comets. Okay. We've landed spacecraft on, well, of course, the moon. And Mercury, we've crash landed. A little C means crash. At the end of the Mercury mission, again, they ran out of money. They're like, yeah, let's just run into the planet, see what happens. So it doesn't really, it's kind of sort of a landing, but not really. Mercury, Venus, as we've talked about last time, we've landed there. Americans a couple times, and the Russians, Soviets, mostly back then, many times. Mars, we've landed on many times, Americans. And out in the outer solar system, now Titan. And we'll come back and I'll show you more about that. Actually, since it's an atmosphere, they had microphones. You can listen to the air on Titan as it was descending, and we'll do that later on. And then for asteroids, we've landed on Eros. That was a crash landing. And for comets, the comet was Tempel 1. That was the crash landing from the Deep Impact mission. And more recently, 67P/C-G. And that was a real landing, though landed in the dark, and so the batteries didn't last long. And then finally, last category here, we've landed humans on only the moon. But I'm actually going to spend some time talking about that today because it's one of our great stories, and I want to show you technologically how we did it, because we did it, back in the 60s and 70s, probably 40 to 50 years before we would have naturally done it. But it was driven, by a number of things. We'll get to it. But for the moon, we've landed people 6 times, and 2 people landed each time. So 12 Americans have landed on the moon and made it back safely. There was another attempt, Apollo 13, which is a great movie. Any of you ever see that movie? I'll assign his homework. You got to watch Apollo 13 with Tom Hanks.
It made me cry.
It's really good. And I actually, I got to go to the premiere, the IMAX, not the real premiere in Hollywood, but the IMAX premiere, which was in Florida. And I got to hang out with Tom Hanks and Ron Howard. And with Tom Hanks, we had a brief conversation. He was telling me how he took astronomy in junior college and failed it. And I told him if he had only applied himself, just imagine how far he would have gone in life. But anyway, it was fun. Okay, so the moon. Do I want another sheet of paper here? Just one sec. Okay, sorry. At the door.
What was the name of the mission in the 80s that failed?
Oh, that was one of the space shuttles. That was Challenger. Or was it Columbia? Those are the two that failed. I sometimes get the order backwards, but yeah. And I'll talk about that as well. So, but let's start, let's talk about the moon landing first, and then we'll talk about new space, what's going on now. So this is, of course, the famous footprint and the famous quote. Neil Armstrong, first person on the moon, and his quote, which actually makes no sense if you try to think about what it means. That's one small step for man, one giant leap for mankind. He meant to say that's one small step for a man, referring to himself, one giant leap for mankind, the team effort of getting there. He says he said the letter A and it was lost in the static of the transmission, but who knows? But that's what the quote was actually supposed to be. Now, this was in 1969, and the whole thing was spurred on by this. What's this? Anyone know?
Sputnik.
Yeah. So this was in the late 50s, and the Soviets launched the first satellite over top of us. It went over top of America. You could see it. Now, how many of you have ever seen a satellite up in the sky? Just a dark night, you look up, let your eyes adapt. Have you seen them? They're everywhere. It takes a little bit to learn how to distinguish them from an airplane. It's a different path. It's very, very uniform, goes across the entire sky. So we're quite used to these things now. Back then, there were only stars up there and planets. And for someone to actually create a new point of light going overhead that we can watch was terrifying because, we were in the middle of the Cold War, and you can imagine this technology very quickly being advanced to include weaponry. And indeed, that has happened. We have intercontinental ballistic missiles. We can launch nuclear warheads at each other. Even though the Cold War is over, those weapons are still all out there, pointed at everybody. So there's always that threat. But it was a very real threat back then. It spurred a big push to try to catch up, a big push with science and technology education in the country. Also, how we ended World War II did that as well. But a big push with the space program to catch up here. And so we put together a 3-part program. And I'm going to give you a little bit more information than I'm going to test you on. I may ask you a few basic questions, but I'm going to give you some details here just because it's really interesting. A 3-part program: Mercury, Gemini, and Apollo. Apollo is what would go to the moon. Mercury was just getting our feet wet, seeing if we can get off the surface of the Earth. Gemini, in Mercury, the capsule holds 1 person. Gemini constellation Twins holds 2 people. And the purpose of Gemini was to learn all the skills that we would need to get to the moon. Both Mercury and Gemini were low Earth orbit missions. And then you had Apollo, which takes you to the moon. And you can see the difference in the size of rockets. To go to low Earth orbit, smaller rockets will do. But to go to the moon, you need a much bigger rocket. I'll come back to that, but here are the rockets. The first 2 Mercury launches were on something called the Mercury Redstone, which was an insane ride. Well, first of all, before we even got there, we set this mission of going into space, and we started building the rockets, and most of them would blow up, with the astronauts, on the ground watching, saying, I'm going to have to get on top of this firecracker and ride it into space. But eventually we got them under control. And the Redstone was the first 2. Those were just suborbital hops, up and back down, like 15 minutes in space. Kind of what private space industry is doing these days. Again, this is just way ahead of when it should have occurred, driven by the political motivations, not by scientific discovery, but by, it's a healthy way to compete. If you're in a Cold War, this is better than, a hot war. To have a scientific or sports competition, that was another avenue that we pursued. Anyway, this thing went up with, I'm trying to remember, I think it was like 11 Gs, 11 times, whatever you weigh, multiply that by 11. That's how heavy they felt going up. Most people pass out under these circumstances. 12 is when fighter pilots pass out without specialized suits. Now, our first astronauts were all test pilots, fighter pilots, test pilots, so they could do this. But that was a hell of a ride. After that, the Gs went down like 6 and 4, but still, I've been in one of those spinning machines where they spun me up to 4G and I thought I was going to die. Mercury Atlas was the rest of the Mercury program. Then Gemini went up on the Titans. Then they started building the Saturn V's. This is a small one just for testing in low Earth orbit, but this is what it takes to get to the moon. And the astronauts ride in this little capsule up here at the top. And here's the space shuttle for comparison. It's smaller than the Saturn V because the space shuttle only went to low Earth orbit. It's bigger than these because it's carrying some cargo. It was designed for satellites and things like that. I'll come back to that in a little bit. So this is Apollo 11. Apollo 1, there was a disaster and we lost all 3 astronauts on the launch pad the day before during a test run. It was a pure oxygen environment and a spark, just one spark, and then the whole thing ignited and they couldn't get out. And that delayed the program tremendously. So we picked back up here with Apollo 11. There was one before this where they went around the moon, but not landing. Apollo 11, here it is. And they go all the way up, walk over, get in this little capsule, 3 of them for Apollo, and off it goes. It's amazing to imagine riding on top of that. And once you get to space, you can discard most of it. Most of this is just fuel. And so you expend the fuel to get off the surface of the Earth and you drop it. And then you're just working with this top piece up here. So you have a couple different components. This right here is the Lunar Module, LM. It's a little launch pad to get back off the moon and the spacecraft. You'll ride in as you go down and back up. Here, this is the command module, the little cone, and this is the service module, which has fuel and things for them to make course adjustments. So once you get out to space, the first thing you do is you get rid of this little tower. And the command module and service module have to exit, turn around, come back, and redock to extract the lunar module. If you look here, you see they're opposite than they are here. So as you're hurtling towards the moon, 20, 30,000 miles an hour, you got to do this weird dance, come and extract the lunar module. If you don't do it successfully, you're not going to land on the moon. It's a very critical step. But then you go to the moon like this with the 2 spacecraft head to head. Once you get to the moon, and this is just a picture of them. This was actually from Gemini where they're practicing docking, they're practicing spacewalks. We actually sent up 2 of these Geminis at the same time and they docked. When you get to the moon, 2 of the astronauts go down the tube into the lunar module. A third has to stay in the command module because back then the computers were as large as rooms, right? So you need a human to actually run this. There's very little computer control of this system. Very primitive stuff. You have more technology in your iPhone than they had on this mission, which is insane. But I always thought it would be the crappiest job, being the one stuck in the command module. You go all the way to the moon and your 2 buddies get to go down and you have to stay there. But they train for these things specifically. They're chosen for these missions in these roles. So 2 of them get in and they go down. This is from one of the later ones. The early ones were black and white. This is a color one, so it's probably Apollo 15 or something. Going down, and there's the command module left behind waiting for them. And they land on the moon. Again, color picture means this is a later one than the Apollo 11 mission. With Apollo 11, they were going down under kind of automated control, and they saw that they're heading for this terrible boulder field, which, we can't tell from here on Earth. You get up close and you realize, oh, we can't land there. We'll never get off again. And so Neil Armstrong took manual control and flew it in a different direction and landed it with, I think, like 11 seconds of fuel left. It was that close to being a national disaster, leaving our first 2 astronauts on the moon. And so they landed. They only spent a couple hours there. Then they climbed back in and this top piece takes off. Later missions, they spent more time. And you leave the booster, the launch pad on the moon. They're still there. You come back up to the command module and dock. And then you ride back to Earth in the same configuration, except this piece has now been left on the moon. And as you get close to Earth, you ditch the lunar module, you ditch the service module, and you're just this cone, the 3 astronauts in there together. You turn it around and you have a heat shield under there, and you ride it back down through the atmosphere. There are no real pictures of this because there's no way. So here's an artist rendering, and you're in radio blackout. No one can hear, you can't communicate during this period. And then the parachutes deploy, and it's a water landing, and you're picked up by helicopters and taken to an aircraft carrier that's been stationed nearby.
Quick question.
Yeah, go ahead.
You mentioned radio blackout. Like, is there a reason for that?
I'm sure there is. It's probably, as they're coming back in, it is hot. They look like a fireball with a long tail coming down, and probably with all that, you just can't get a transmission out through it, would be my guess.
Okay.
Now, you've always had your moon skeptics that said the whole thing was done on a Hollywood stage. One of my favorite astronaut stories happened about a decade ago, where one of these guys came up to an aging Buzz Aldrin and wouldn't leave him alone. And he just decked him and knocked him out, and the police wouldn't file charges against Buzz and just let him go away. But anyway, we've since gone back to the moon in orbit for other missions, scientific missions, with better camera technology. We can't find these from Earth. The moon's too bright and too big. But in orbit, yeah, we found all the landers. Here are some of them. Not the best images, but here's Apollo 12. You can actually see where they walked, the footprints and some of the scientific missions they left behind. Here's Apollo 17, where they had a buggy that they would drive over longer distances. So it's all there. We really did do this. Although I hate conspiracy theorists, I can understand a little bit of skepticism, because this should not have happened for 4 or 5 decades. They were just motivated by the Cold War that we made this technology so much sooner than we naturally would have. And it was paid for by, funded by taxpayers instead of, capitalist self-interest, which is kind of what you need to do it in a large permanent way. Anyway, then we switched over to the space shuttle program, because once we beat the Soviets, that was the reason to do it. It wasn't the scientific mission. The plan wasn't to create a moon base. So we stopped doing it, and NASA moved into low Earth orbit, the space shuttle program, beginning in, I believe it was 1980. It ran for a long time. We had a number of orbiters. As we mentioned before, we lost 2 of them, one in 87, and the other one, I forget when. I think it was the early 2000s. And it wasn't the best design. They're flying death traps. If you lose 2 out of 5, that's not good, though they did run for a long time. And actually, after we lost the first one, the reason to have them was to launch large satellites, communication satellites and military satellites. A lot of the missions were classified. You didn't know what they were taking up. But after we lost one, no one wanted to put their satellites on the space shuttle. They wanted to launch them on traditional rockets. So we had the space shuttle program with really no purpose. At that point, we started building the International Space Station. This may be a little cynical of me. Yeah, it was sold as a place where a lot of science would be done, but not a lot of science has been done there. Most of the time, it was understaffed until just recently. It was really to give the space shuttles a place to go, in my opinion, which is probably not the best thing from a long-term vision point of view, but it's the path we took. And we now have this beautiful space station shared between us and the Russians and other partners. But moving forward, so this is getting into new space a little bit. And let's see, I have about 5 minutes, so I'll try to wrap this up. I'll go a little quick. Let's start with NASA. Their plan moving forward was to build rockets akin to the Saturn V. The space shuttle was not a good design. Stuff from the top falls down on the orbiter, damages it. That's how we lost the second one. So we're going to go back to the capsule design where the astronauts ride on top. Nothing can fall on them because they're at the top of the rocket. And these would be big rockets capable of going back to the moon or Mars. I think they've changed the names a couple of times, but at one point this was called the Constellation program. These are Ares rockets on an Orion capsules. And here's a drawing of one. It would carry 5 people to the moon, and all 5 could go down. The computers could run it otherwise. But with NASA, it's taxpayer funded, so it's limited. Every time we get a new president, we get a new direction. And so it's hard for them to make progress. This is something where I believe the private industry can do a better job. And under the previous president, every president comes in, changes the direction. Obama's direction was to create partnerships with private industry to spur along private space industry. And there have been a number of players. Here's Elon Musk, who used to be like my personal hero, but now he's like 50% awesome, 50% total annoying crackpot. But he's done some amazing things from his Tesla car company, which I think is now valued higher than Ford. That's impressive. But SpaceX, and there are a number of companies out there, but none have achieved what SpaceX did. His whole thing is reusable rockets. When NASA builds a rocket, they build the rocket, they use it, and they dump it in the ocean. It's like if you wanted to fly to the other side of the country, build a 747, fly, and then throw it away in the ocean. It's not very cost effective. What Musk has figured out how to do is to return at least the booster part back to Earth and then reuse it. It brings the price down tremendously. And his next generation one, the thing will be 100% reusable, and it will be of scale to go back to the moon and to go to Mars. But this one was extra fun. This was a number of years ago. This is the one where he launched his Tesla in a Mars orbit into space. But it was a Falcon Heavy, so it was 3 of these together. One was supposed to land on a barge out in the ocean. It didn't. It's harder to land on the barge. But these 2 things came down and landed simultaneously right from where they took off. It's super impressive. I was going to show you the video, but we're running short on time. And there's the Tesla in space. It's actually going to go back and forth between Earth and Mars for like all time. And he's been building capsules to resupply the space station, and now they are being used by astronauts. For the first time in a long time, we don't have to hitch rides with the Russians, which is kind of nice. And then here's his new rocket, which he's just now testing and developing. It used to be called the BFR, for Big Effin' Rocket, but now it's called Starship. But it's not all about Musk. And it's not all about, he's making his money launching satellites and launching people for the International Space Station. But there's a burgeoning space tourism industry. And I'll probably end with that. This is Spaceship One. There was a Google X Prize worth like $10 million. It's not enough to cover the technology development, but it helped. The prize was reusable spacecraft. Can you make a spacecraft that you can carry a few people and relaunch it 3 times in like a month or something? And Spaceship One was the first to do it. It would ride under the white night, and then it drops and fires its engine and goes up. And it's suborbital, just 15 minutes, and then it comes back down. This was a big enough achievement that if you go to the Smithsonian, you can see it right next to the Spirit of St. Louis, etc. Now they're doing Spaceship Two, which is larger, designed to carry, I think, 7 tourists. And they've already sold zillions of tickets. It's a $250,000 ticket, I think. They will eventually come down so us mere mortals can afford it. But you start with the rich paying for the R&D development, and once it becomes more standard, then we get to take these flights. They should have been up by now, but they did have an accident, and they lost one of their spacecraft and an astronaut. I think the other one survived. I'm trying to remember, but that slowed them down. But I imagine in 2021, Spaceship Two, riding under White Knight 2, will be back in action, and we'll have space tourism. And then, that's suborbital. Eventually, they're going to have to go orbital. And once they do, you have companies like Bigelow. They're a hotel company building inflatable space stations. And this is where you would go. If you're going up for tourism, instead of just orbiting the Earth, you have a place you can go. And it's not just this is just a drawing, but they've launched a number of them, small ones, and there's one attached to the space station. It just inflates, and you have tremendous volume at much lower cost. And the idea is you can piece these things together and make little mini cities up there. Oh, and then, yeah, that was it. There's me and Tom Hanks and me and Ron Howard, back when I had more hair. So anyway, I think that's it for today. And next time, we'll start working our way through the planets one at a time, beginning with the Earth. Okay, I'll stick around for questions.
Thank you.
Quick question.
Yeah, go ahead.
Thank you.
My pleasure.
This might be slightly, I don't know if this would fall into the field of astronomy, might be more physics related, but are there any like companies or like anyone researching like how to like build a space elevator?
Yeah, that's an interesting topic. I've read kind of popular articles on it. I'm no expert, but the idea is it's this long tube and it has to be strong enough to hold itself together. I'll get rid of me and Opie there. It has to be strong enough to hold itself together, as Earth is rotating. And then you don't have to use rocket fuel. You just ride up this tube. And I think they're, working on carbon fiber technologies and things like that, extra strong tubes, because you throw Earth's rotation on this long tube and they can bend and crack and it's difficult. But eventually that will be the way to go to low Earth orbit. And it's a little beyond us technologically at the moment, but in time. I read something recently that an easier way to do it would be off the moon. So, if building from the moon coming down, so maybe you still do a traditional ride into space, but instead of landing on the moon, you just kind of hook up at the top of one of these elevators. And the rotation is much slower on the moon. It goes around once a month instead of once a day. The gravity is less. So we might see them there first before coming off the Earth.
And would it be better like to, instead of a tube, would it be better for a cable or since a cable is less sturdy, that would make it less reliable?
Yeah, I don't know if it's a tube actually, or it's probably, I think they usually talk about cables and you're probably riding on the outside, but the cable is like ginormous, right? And so tube, I'm thinking of the cable. Yeah.
Yeah, okay. Thank you.
Any other questions?
Which do you think's the better Cosmos, the one with Carl Sagan or Neil deGrasse Tyson?
I mean, they're apples and oranges. I guess I'm partial to the original because that's the one that got me excited. Though I haven't watched it since I was a kid. If I were to watch it today, I'm sure parts of it would feel very dated. I do like the use of animation that they've introduced in the new ones. And I haven't seen the most recent one. I've been waiting for you to be able to access it for free or for cheap. They put it out on some, pricey, obscure services that I don't want to subscribe to. But they've used a lot of animation. I think it's worked out pretty well, actually.
Wait, did they make another season of the one with Neil deGrasse Tyson?
Yeah, there's another one. I'm trying to remember if it's the second or third one now. I think it's just the second. Yeah, there's a second Cosmos with Neil deGrasse Tyson that's out there. It was done with National Geographic, but it's so far it's only on these obscure streaming services where you have to like pay $50 a month and you never use it for anything but this. But in time, you'll be able to get it on Nat Geo through the Disney Plus option.
Oh yeah, I hate that we have to use like 20 different streaming services now.
I know. Yeah, I just try to be patient. If I know it's going to go to one of the ones I have access to, I'll wait.
Yeah. All right. Thank you.
Sure.
Have a good day, Professor.
You too.